Our next set of rules are for changing product of trig functions to sum of trig functions. Here's our first one. So if we have cos, now basically if you think about where it came from, it must have come from the cosine alpha plus beta formula, because that's the one that has cos in it. So if we have cos of a minus b plus the cos of a plus b, then you're going to get cos plus sine, and then you'll get cos minus sine. You'll be left with two coses. Okay? So our cos comes from the cos alpha plus beta. Now if we have sine cos, that must have come from the sine formula, because we would have had sine cos minus cos sine plus sine cos plus cos sine. So the cos sines would have cancelled. And then the last one is the sine. Well, that must have also came from the cosine one, but now we must have subtracted instead of adding, so that we're left with the sines. Because if you think about it, we would have gone cos plus sine minus cos minus sine. So we get two lots of sine. So they're the three products to sums. As I say, if you forget, think about it logically where they must have come from. So cos must have come from cos, sine must also come from cos, and the sine cos must have come from the sine. So if we wanted to change this expression to cos sine into a sum or a difference. So cos sine, now don't get confused here, because you go, hang on, cos sine, we don't have a formula for cos sine. We've got a formula for sine cos. It's the same formula. I'm going to change that to sine cos, just so it matches my formula, and I don't make a silly mistake with that subtraction of the a minus b. I know it's the first one minus the second one. So it'll be sine of x minus 5x plus the sine of x plus 5x. Notice in all three of the formulas, the a minus b comes first. I've deliberately set that up. I mean, when you think about it, it doesn't actually matter in the first two, but I've deliberately done that way so it's consistent all the way down. So we get a minus b first. And we get the sine of minus 4x plus the sine of 6x, but then I'm going to take advantage of sine being an odd function and change that to minus sine 4x. So we get minus sine 4x plus sine 6x. All right, let's try a cos. So cos must have come from the cos, and so we'll have a half of, because notice the formulas are two lots of. So again, so I don't confuse myself, I'll rewrite it as a half of 2 cos, and that was cos of a, oh look at that, I've contradicted myself, I put the plus first, didn't I? Oh well, oops. But we get the 3 theta plus 5 theta, and the 3 theta minus 5 theta. Now cosine, even function. So the cos of minus 2 theta would be the same as cos 2 theta. So if we had to work out 2 sine 45 cos 15, well, sine 45, we know the exact value for that. Cos 15, well, I could work it out, I suppose, but rather than doing that, I can change this product to a sum. So it's sine cos, must have come from the sine one. So we'll get the sine of 45 minus 15 plus the sine of 45 plus 15. Both of those become exact values that we know. So it's probably a bit quicker to do it this way. And so we'll get a half plus root 3 on 2, 1 plus root 3 on 2. As I say, it would have been perfectly valid to work out what the cosine of 15 is and then substitute that exact value in, but I just think that's going to take longer, that's all. We're going to prove that sine squared 5 theta minus sine squared 3 theta is the sine of 8 theta sine 2 theta. Okay. Well, seeing we're doing products to sums, it kind of makes sense to work with the right-hand side first. So I'm going to start with the right-hand side. So it's sine, which must have come from the cosine formula. But I've got a half of 2 sine, so I'll put the half out the front. comes from the cosine formula. We always put the minus first. So it'll be cos 8 theta minus 2 theta. But because we want to be left with the sine part rather than the cos part, we'll subtract instead of add. And we'll get cos of 8 theta plus 2 theta. We end up with a half of cos 6 theta minus cos of 10 theta. Now, how on earth do we get to sine squared 5 theta minus sine squared 3 theta from there? Well, I'm going to use double angle results because I notice I've got 6 theta and 10 theta. My answer wants 5 theta and 3 theta. So the angles I have are double what I want. So the cos 6 theta, I'll change to 1 minus 2 sine squared 3 theta. Makes sense to use the sine squared one because that's what they're asking me to prove. And the cos 10 theta will be 1 minus 2 sine squared 5 theta, but it's minus all of that. So we get minus 1 plus 2 sine squared 5 theta. Tidy that up, we get a half of 2 sine squared 5 theta minus 2 sine squared 3 theta. The halves cancel with the 2, and eventually we get to sine squared 5 theta minus sine squared 3 theta. So quite a bit of work to do with that particular one. That was products to sums, which is in the syllabus. But for some reason, sums to products is not in the syllabus. Well, we're going to look at it anyway, because it just makes sense. If we go back the other way, sine plus sine. Oh, well, there you go. 2 sine half a plus b cos half a minus b. It's a bit clumsy remembering that way. There you go. 2 sine half sum cos half diff. Right, so sine plus sine, 2 sine half sum cos half diff. Cos plus cos becomes 2 cos half sum cos half diff. And cos minus cos becomes minus 2 sine half sum sine half diff. Now, how on earth do I remember all these? Okay. Well, they all start off with 2, other than the minus 2, but I mean, they're all starting off with 2, so that's the easy bit to remember. Now, if you'll notice, the sine plus sine starts with sine. So that's easy to remember. The cos plus cos starts with cos. So that's easy to remember. And both of those go then half sum. So I'm always going half sum. They both end in cos half diff. So for the first two, when it's the additions, so sine plus sine or cos plus cos, it's just 2, whichever ratio I'm playing with, half sum cos half diff. Cos minus cos. Well, in my weird head, when I see cos minus cos, I go, ooh, that's a bit different, because the others are plus. So then I know my answer's a bit different. So instead of starting 2, I start with minus 2, because that's a bit different. And instead of starting with what we've got, I start with the other one. Well, that's a bit different. So I'll go sine half sum. And instead of ending with cos half diff, we end with sine half diff. That's a bit different. So when it's the minus there, I just know, oh, this is the one that's a bit different. So instead of starting with 2, I start with minus 2. Instead of matching it, I don't match it, so I go to sine. And instead of finishing with cos, I'll finish with sine. Easy, hey? As I say, it's a strange place inside my little head, but that's how I think. So I've got to prove this one. Cos of 75 plus cos 15 over sine 75 minus sine 15 is the square root of 3. So on the top, we have cos plus cos. On the bottom, we have sine. Oh, hang on. I didn't do a formula for sine minus sine, but there's a reason. Because sine is an odd function, I can change the minus sine 15 to a plus sine minus 15. So I don't need a formula for minus. Now, I think you'll find in textbooks they have a formula for minus. I just don't worry about it, because then I can keep it my nice, neat formulas that I have. So on the top is cos. So it will start off 2 cos half the sum. Well, 75 and 15 is 90, so half of 90. And we always end with cos. So cos half the difference. And the difference between 75 and 15 is 60. On the bottom, it's now sine plus sine. So I'll go 2 sine half sum. But now it's 90. Now it's 75 minus 15, because I'm adding the negative 15. So it becomes 60. Cos half diff, 75 minus 15, which is 90. So we end up with the cosine of 30 on the sine of 30, because the 2's cancel. Oh yes, we've got cosine of a half 90 on both top and bottom, so they cancel. And we're just left with cos 30 on sine 30, which is the cotan of 30, the square root of 3. Okay, let's solve this equation. Sine x plus sine 3x. So it's sine plus sine. I'm going to turn this sum into a product. So we'll go 2, it's sine, so I'll start with sine, half the sum, x plus 3x is 4x, so the sum of that is 2x. We always end in cos, so cos x minus 3x is minus 2x, half of that is minus x is equal to 0. Well, cosine's an even function, so cosine negative x is the same as cosine of x. And now I've simply got, hey look, these things multiply together to give 0, so either the sine of 2x equals 0, or the cosine of x equals 0. Well, sine of 2x equals 0, we'd be going around the circle twice. So we'll get 0, 180, 360, 540, 720. Divide by everything by 2. Cosine equals 0 is just 90 and 270. So all up, there are my values. 0, 90, 180, 270, 360. All right.